What's up, Algebra 2? Here we are with our Standard 1A Summative Review. Okay, required to be completed before you can take your summative test. Okay, here's the half that we did in class. Alright, this should be 1 through 4. We're solving each system using substitution and elimination. Okay, so we did the left side. Okay, number 3 has a y equals already in it, so that's going to be a hint that it's going to be substitution. So I'm probably going to feel like this one's elimination. Also, it has a negative 1y with a positive 2y. Okay, it makes it a little bit easier to do elimination. Signs are already different, and I just have to multiply the whole top row by 2. Take that 2 to everything. We'll have 8x minus 2y equals 36. Let's do a one light scribble through that. Okay, and we add down. Adding down, we're going to get 14x. Those are going to cancel. Equals 49. Divide by 14. And Mr. Handke, this one doesn't work out perfect. What do we do? Okay, you can reduce this by 7s. We'll have 7 over 2. Or 3.5. Okay, a half is not a terrible fraction. A 3.5 is not a terrible decimal. Okay, it might not be perfect numbers on the test. Okay, a 0.5 or like a 0.25 would not be out of the question. Okay, now if you get like 3.5, 7, 1, 2, 8, 9, 4, 1, okay, that's going to be a bad situation there. You probably did something wrong. But a 3.5, that's a pretty friendly decimal. Okay, now you got your choice of any of those 3 equations to plug this back into for x and solve for y. I've been doing the top one. 4 times x, 3.5. Minus y equals 18. Okay, we got 14 minus y equals 18. We're going to subtract 14 from both sides. Don't lose that negative. Negative y equals 4. That means positive y would equal negative 4. And our answer is 3.5 comma negative 4. Alright, so that is elimination. Substitution, number 3, we already talked about that a little bit. Hinted at it that it's a y equals already. Perfect setup for some substitution. We're going to take what y equals and we're going to plug it in there for y. So we're going to have 3x plus 2 times, not y. We're going to plug 2x minus 4 in place of it. See how that's going in for the y spot because it's equal to y, so I can substitute it in there. We're going to distribute this times 2. 4x minus 8. Okay, put your x's together. 3x plus 4x is 7x. And let's add 8 to both sides. $7x equals 21. Divide by 7. X equals 3. We got our x number. Okay, and we also have this really friendly equation that says y equals. Let's plug that 3 in for x. Not 2x minus 4, 2 times 3, because I know what x is. So we're going to have 6 minus 4, y equals 2. 3, comma, 2. Alright, so there's your substitution and elimination. Okay, you'll have something similar to that on your test. Solving systems using matrices by hand. Okay, step 1, we got to turn this system into a matrix. So we're going to do our coefficient matrix, all the coefficients in front of the variables. Times xy equals 4, negative 6. Okay? Now, in order to solve this, you're going to multiply the inverse to both sides in the front. The front of both sides of the equal sign, but I don't know what the inverse is. You have these on the top. Okay? This is how you get the determinant, and then this is the formula to use the determinant and that original matrix to get the inverse. So our determinant is the difference of the diagonals. So 2 times 2 minus negative 3 times negative 2. So we're going to have a 4 minus 6. Our determinant is negative 2. Okay, now we're going to take that 1 over negative 2, and we got to do some flip-flopping. These two flip-flop spots, you're not going to be able to notice it because they are the same number at this particular time, but this number goes down and this number goes up. And then these two numbers change their signs. So if it's negative, it's now going to be positive. Negative, it's now going to be positive. Okay, I like to multiply this in. If you have a different teacher who taught you something else, you can leave it out there a little bit. I like to multiply this in. We'll have negative 1, negative 3 halves, negative 1, negative 1. That is our inverse. Okay? We need that in the front of both sides of our equal sign. So I'm going to put that right here. Negative 1, negative 3 halves, negative 1, negative 1. Okay, and then we're basically copying this down again, our original matrix equations. Okay, don't forget to put it in the front on the second side here. Alright. Now, we did this the long way one time in notes, and we said never again. Okay, the inverse and the original should cancel out, leaving us with xy over here. Okay, on the right, we're actually going to do this. Let's see the math. Okay, remember it's row times the column. So the first number in the row times the first number in the column. You're going to have negative 1 times 4, and then negative 3 halves times negative 6. So that's going to be negative 4. Negative 3 halves, or negative 1.5, times negative 6 should be a plus 9. And negative 4 and a positive 9 make for a positive 5. And then we do row times column again. This time it's the bottom row times the column. Negative 1 times 4 is going to be negative 4. Negative 1 times negative 6 is a plus 6 for a 2. So we have 5, 2, or 5, 2. Okay, a lot of work there. Equations to matrix form. Okay, take that coefficient matrix and find the determinant. Use your determinant and your inverse matrix formula. Determinant formula, inverse matrix formula, to get to inverse. Take that inverse, multiply it to the front of both sides of your equal sign. These will cancel out. XY equals, and we do some row times column matrix multiplication, and we get 5, 2. Backside, verifying that they are, or proving that they are inverses with 2 by 2s. Okay? So we're going to multiply them together, and when we multiply these two together, it should be 1, 0, 0, 1. But you have to prove that. You can't just say it does equal. So we're going to have a work matrix here to actually show our multiplication. Alright, and then it better equal 1, 0, 0, 1, or they're not inverses. Alright, so we got row times column. So we got 1 times negative 7, 4 times 2. So that's going to be negative 7 plus 8 for a 1. Okay, then we're going to go 1 times 4, 4 times negative 1. 4 and a negative 4 is going to be a 0. Row with column again. Sorry, I didn't put the arrow there. Row with column, negative 14, positive 14. For a 0. And then we're going to have 8 and negative 1. 8 and negative 7 for a 1. Alright? Now, we got 1, 0, 0, 1. So you're thinking they're inverses, but just to be safe, we're going to have to flip these around and do it again. Alright, I'm going to jump you to the shortcut here. Jump you to the end and show you the answer from a different class earlier. Okay, so we flip them around, and you notice that the work matrix is going to be different, so you need to make sure you do it, because I'll know. And we have 1, 0, 0, 1 again. Yay, they're inverses. Alright, then our last problem, the story problem. Okay, we need to make sure we go through and label what's going to be our X, Y, and Z. Mr. Handke likes to do this right here on the problem. You can do it off to the side and say X is pencils, Y is erasers, and Z is notebooks. Next, we have to actually do out the equations. And I'm running tight on time here, so I might just cheat a little bit. Okay? We have to actually write out the system of equations. 7x, 4y, 3z, $8.25. 226, boom, 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 $9. Okay, you got to write this out. Then you're going to take that into matrix form, 743, 226, 654, XYZ column, answer column. Also something that's very small but also very, very important. Okay, we're going to multiply the inverse to both sides. You have to have that A inverse down there. So A inverse times A cancels out. We just have our XYZ. Then we have A inverse times B. And this is where we're typing it into the calculator. Okay? We're doing second matrix. Slide over to edit. And it's a 3 by 3, and we type them all in. 7, enter, 4, enter, 3, enter, 2, enter, 2, enter, 6, enter, 6, enter, 5, enter, 4, enter. Okay? Then we do second matrix, edit, and we edit our 3 by 1. And we make sure that's a 3 by 1 for matrix B, and we type in our answer column. Okay? Now is the tricky step. Second, quit. Back to the matrix, second matrix. Now we're not editing, we're ready to use them, so we're going to use them under names. Matrix A, inverse button, x negative 1, A inverse, times second matrix B. Okay, and that's exactly what we have here, A inverse times B. Ta-da! Alright, and you need to show me that you understand that this is money. Okay? So it's going to be a little ticky-tack thing. If you don't have like the money symbols in there, then it's going to be a half. So make sure you put that money symbol in there, or whatever label would be appropriate. Alright? If you need more help on the 3x3s, look back to a previous lesson in Standard 1A for the video on 3x3 matrices. Alright, thanks for watching, and good luck on your test tomorrow.